Let's take a look at a code example of the abstract factory pattern. Our application needs to support both SQL Server and OLE-DB databases, but we don't want the entire application to have to deal with the different kinds of commands and connection objects that are used for those databases. We actually don't even want our data layer to support that either. We simply want the factory pattern to be able to give us the right database class, and the rest of the app doesn't have to know anything about the underlying technology of the database. So we get a nice separation of concerns that way. This is our class diagram. We have an abstract class called database. It has two properties, a command property and a connection property. We're going to have two classes that inherit from database. One is a SQL Server database, and of course, it implements command and connection. And we have our OLE-DB database, and it implements command and connection. In both cases, we have corresponding private fields as well. The rest of the class diagram consists of the things that we have in this Windows Form app, which doesn't add up to much, and I'll show you that later. So let's take a deeper look at what the factory pattern classes look like. The database class is very simple. It simply has our two properties, connection, which is a DB connection type, and command, which is a DB command type. And both are just empty virtual properties. Note that we're using DB connection and DB command. These are abstract versions of connection and command objects for .NET that can be found in system.data.common. These are the objects that the rest of the application is going to be working with, but they don't expose the database technology. In our implementations, we have a SQL Server database class, which descends from database. It uses system.data.SQL client and does not use system.data.common. We also have a using system.configuration, and I'll talk about that in a little bit. We have our private members of DB connection and DB command type, and we initialize them to be equal to null. I like to do this explicitly just to make sure that it's clear. And then we have our property. We have a public override of DB connection type for our connection property. If our member is equal to null, we're going to create a new connection object. Note that if the member has already been set, then we don't go through the process of creating a new connection. This is called lazy loading. So we haven't created the connection until we actually need it because someone has requested it, and we don't recreate it all the time that they request it. We're going to get the connection string from the configuration manager, its connection strings object, and we have SQL Server connection string as the name of the connection string for the SQL Server database. And we'll get the connection string property from that. So this is information that's stored in app-config, and if this was a web application, it would be in web-config. So if I open up app-config, I have connection strings for both SQL Server and OLE-DB. This sample code is going to be in your work files, and you'll obviously have to change the connection strings for whatever system you're working with. But the SQL Server connection string has a data source, an initial catalog, integrated security equal to true, and most importantly, its provider name is SQL Client. And you can see that the provider name for the OLE-DB connection is system.data.OLE-DB. So that's what our configuration looks like, and that's where we're going to get the connection string property. The one other thing we need to do in order to use the configuration manager, in our references, we have to add system.configuration. That doesn't come for free. So now we have our connection string, and then we can simply create a new SQL connection object, passing in the connection string as the parameter. We'll set our connection member and return it. Now note that I've created a SQL connection, but the return type is DB connection. And that's simply because SQL connection inherits from DB connection. The other property we have is the DB command type command property. And it follows the same sort of pattern. Again, if the member is equal to null, we'll create a new SQL command, and we'll set its connection property equal to the connection that we've created. So from the application's perspective, when it asks for a command object, we actually create the underlying connection object and set the command's connection. So the application only has to actually ask for command. So that's the SQL Server implementation. The OLE-DB, as you might expect, is very similar. The only real change is that we're using system.data.OLE-DB. We're getting our connection string in the same way, except of course we're passing in the OLE-DB connection string name. and we're creating an OLADB connection as opposed to a SQL Server connection. The process is the same, however. And for the command, we're creating an OLADB command as opposed to a SQL Server command. So these are the classes that comprise the abstract factory pattern. Now let's see how we actually use them. In our form, we've got a very simple form design. We have a radio group that asks to use SQL Server or OLADB and a simple Get Database button. That button click handler is going to create our database object. And if our radio button for SQL Server is checked, we'll create a SQL Server database. Otherwise, we'll create an OLADB database. Now note my variable for database is of database type, so it's of that abstract class type. So after we choose the type of database based on the radio button selection, the rest of it is all generic. The rest of the application doesn't know anything about it being SQL Server or OLADB. All it knows is that it has a database, and there's a command object on that database. And you can see we take that command object, and it's of type DB command. It's not SQL Server or OLADB command. And then when we have that command object, we can run our database operations. So I've commented those out here, but just to give you an example of what you might be able to do, you can set your command type on that command object. In this case, I set it to text. And then you can set your command text. So I've typed in some SQL. In best practices, we'll do this a little bit differently. Then I can call connection open on that command, create a DB data reader, and do an execute reader on the command. Finally, I can close the reader and close the connection object. Obviously, in between creating the reader and closing it, we might actually want to read some of those customer records. But note that none of these calls know anything about SQL Server or OLADB. So the rest of the application is completely isolated from that database technology. So we could expand this factory if we wanted to include MySQL or Oracle or any .NET supported database technology. So if you had a database application that you wanted to switch over from SQL Server to Oracle, if you use a factory pattern, you wouldn't have to rewrite the entire application to change all of those SQL client objects. You would only have to add the Oracle implementation to the factory, and then just change the code that calls out which factory to use. So you'll get the Oracle factory instead of the SQL Server factory, and then everything would be using the standard abstract DB commands and DB connection objects. So in that way, you could actually make a shift from one database type to another fairly simply. Now this is a pretty basic example, and you might actually want to go a bit further so that you don't actually have DB commands and DB connection objects in your application code. You probably actually want to hide those in a data layer to provide more isolation for the rest of your application. But the abstract factory is a start at least isolating the database technology.